G'day all, welcome to another go at concurrency with 7 billion humans. Let me just make sure I've got all my bits and pieces lined up. I suppose notifications go out, then we wait a little while. Is that how this goes? You have to teach me how this goes. I'm an old man, I don't know. Let's have a quick look where we were. 7 billion humans. I'm on the big computer this time, so hopefully we get the levels all right. Still learning. Slow and steady. We've got a cutscene here. Let's spend a few minutes watching a cutscene while people potentially tune in. Got my tea. Intro to morale officers. I can't hear them because I've done something weird with the volume. I didn't want it coming through two different paths. I should just turn that one down, turn this one up. Rah, rah, rah. The cutscenes are cute and all. Don't blow my mind, but it's good that they're in there. Otherwise I think we'd be looking at a fairly laborious process, and it does kind of unfold a story little by little. All right, dynamic angles. Let's have a look. What is happening here? All right, we have to put these guys down. I remember this one. We're going to soon get to the ones that I haven't done yet, but not yet. See the nice steady straight horizontal line of data cubes. Let's be wild and turn it into a diagonal line. Okay. This is the place we hit the point where the one process, when human, is dependent on what another human's doing. So they have to cooperate in some sense. But just like normal processes in a program, they don't generally cooperate by talking to each other. One of these humans can't say to another, I'm done. The way they do it is by looking at what's been left behind by the other processes or the other humans. So in this case, if I've got a box to the left of me, right of me, whichever side it is, then I do want to move forward and put another one down. And if I've got a blank spot to that side, then I want to put mine down. But that's not even going to work in general, because if the person next to me's moved faster than I have, then there won't be a blank spot. There'll be a blank spot to me next to me, but I don't want to put something down. All right, let's start experimenting with this. So I definitely want to step forward and pick up, no matter who I am. I can hear my fan going absolutely mental behind there. Hopefully it's not causing you guys trouble. I guess you can hear it as well as I can hear it, so I apologize for that. This is why I was doing the streaming before on the Linux box. Linux box has got more thermal headroom than this little Mac Mini here, which is basically just getting worked half to death here. Let's check the task manager to see what's killing it. I mean, I'm sure it's the game, just using it, whatever it's got available. Oh, actually, it's it's OBS doing the hard work. Maybe if I minimize it, that'll save us a few cycles here and there. Nah, probably not. All right, back to action. So step and pick up, definitely. I'm going to just step this a few times. I'm trying to get some inspiration here. I haven't got any yet. So they're all lined up, which is what I want. So, I mean, there's a human next to me. I mean, I can think of something straight away, right? Which is, I got this if statement. I definitely need to use the if. The if determines whether to keep going or not. So I can only use what's in the if. That's to a direction. And these things, whatever these things are. something, nothing, a worker, a data cube. Look, I'm going to do it off a worker. Fully aware that that could go wrong if the workers go out of sync. Actually, if I ask for data... Oh, I'm going around in circles on this one, aren't I? I apologise for that. Let's step forward, and if next to me is a blank spot, is a nothingness. Okay, so to this side is a nothingness. Then I've stepped one past the last block, and I can put mine down. And if not, then I want to step forward and then try all that again. Just step one step forward and then try it again. So this is my loop. Let's run that and see how we go. So they all pick it up. It looks left. So she looks left and sees nothing, and he looks left and sees nothing. He looks left and sees nothing. He looks left and sees nothing. So that works absolutely fine. What I'm getting at here, and I think that's probably the answer they're looking for, but what I'm getting at here is if these humans had gone out of sync, if this lady here, number 35, had walked forward before number 86 had looked left, then number 86 would look left and see a blank spot and put his down. So not good. But maybe I'm just thinking too far ahead. So none of mine have gone wrong. And in fact, I got the speed challenge. Should we try for the size challenge? In the size challenge, I've got to drop off 2 instructions. So I probably want to pick up in front of me and then always step 1 and then take out that step. And I can also take out the jump to get rid of the else. So now I'm down to 5. I think that does the same thing. They'll keep walking off into the distance, but I've got less. Cool. So I think I saved the instruction. Yes. Good. Ah, and it was the fastest one. So let me get away with something there. Which one should we do, 10 or 11? 10, I guess. Just received a fax. Experiencing impressive, stunning fanfare. That's nothing. Structural failure. We're going to exit the room. This one's... One of the holes in this room has a nice fluffy exit chute below it. And you'll be carried to safety. All the others lead to painful splattering doom. Find your way, just follow the instructions over there. So the instructions are that a data cube of 1 tells me to step up, a data cube of 2 tells me to step right, data cube of 3 says step down and step left. So we can actually see these here. 1 is telling me to step up, 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 then left, left, then down, 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 down. So actually all I got to do is just follow these data cubes. Nice. So each person's just going to walk over and follow the data cubes, I suppose. So the first thing we've got to do is just step left till we hit a data cube. So step left. Well, let's surround that in the if that checks to see where we're on a data cube. Equals a data cube. If it's not equal to a data cube, then please step left and jump. So just keep doing that because they're all starting in different positions, so I don't know exactly how far they have to jump. And then if you are standing on a data cube, then jump out of this if statement, please. Don't think I need that at all, right? That else jump to here doesn't do anything, right? If I just left that out, then I would get to the exact same place. So let's pull those out. So if you're not on data cube, step left, jump back around, look for a data cube again. If we're standing on a data cube that has the number 1, then step up. Okay, cool. Did some of the program for me. And I want to do the same thing for all the others, right? If I'm standing on a data cube that says 2, then I want to step right. Notice how they took away some of my instructions for this one. They're just giving me the instructions that I need. Interesting. I haven't shown you this yet. This is a comment. You can drop a comment in and scribble on it. Works better on a touch screen, I suppose, because these schemes are available for iOS, I think. Cool way of commenting your code, I think. This is asking for help. Drag commands to learn more here. Yeah, we're good. So if the data cube we're on is a 3, then step to the 3 says step down, and 4 says step right. So hopefully, this is not enough though, because we still need the jump. All this needs to be in a loop. Number 4 is my step left. Step left, and then I need the jump to say, look, you've done all that, head back around. You'll be standing on another data cube. So if they ever get on a spot that doesn't have a data cube, they're just going to stop. That doesn't belong in the else, that belongs above the if. Thank you. So this is the loop for going around and looking at each data cube you're on. Let's run it super fast. Off they go. Oh, we're jammed up. So 3 is wrong. Oh, there we go. I accidentally had if 2. So I didn't change that to 3, which meant there's no if for when you're on 3, which means this guy's just stuck here and no one else can move. That's what we call a deadlock in concurrent programming. That's actually, that is exactly a deadlock, right? We've gotten to the point where every process is waiting for that process to do its job before they can do their jobs. And they're all just spinning their toes, spinning their wheels. Very nice. All right, I guess we demonstrated a deadlock, which I wasn't expecting to do. So you'll discover in concurrency that there are deadlocks and live locks and state errors. Whole new classes of errors that you never used to get in your programs that you can get now when you're doing concurrent programming. All right, the 3 is pointing us in the right direction, and off they go. There's something happening in this program we haven't been told about yet, which is what happens when they don't know where to go, like when there's someone in their way. We saw a little puff of dust come up. That's probably what happens. But it gets a bit more complicated a little bit later. Good work, we're good. Ha 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 ha. Yes, managers who don't know how to program. Surprise, surprise, hearing a joke like that coming from a programming team. Yes, 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 continue to the elevator. 11 or 12? Oh, 12 is unzip. Let's do this one. Every time you see the word zip in a program, you get interested because zipping and unzipping arrays of data, streams of data, things, trees is just great fun. Let's unzip that line of data. Move the leftmost data cube up, then move the next cube in the line down, then the next one up, down, you know, like unzipping a zipper. All right, he's already started, maybe. So if you're to the left of me is a wall, then step up. I love his little picture of himself. Yep, that's probably what we're going to do. And drop your thing. But what do you want to do for everyone else? So the next person will see to the left of them a blank spot. And that will make them want to move down, right? So I mean, I can just, this is the step 1 step line. Let's follow him. And he's going to do what we want him to do. He's going to pick up and he's going to look and see a wall. So he's going to step. Everyone else has just jumped out of the program because there's nothing else for them to do. And he's dropped. So how do we get the next person to do what we want? Well, we say if to the right of you is left of you is a nothingness, then why don't you go down? It's not going to work for everybody though, is it? Because then she'll go down, and he'll go down, then him, then they'll all end up going down. I had trouble with this one when I did it the first time, and I'm going to have trouble again. So please give me suggestions on the feed, on the chat. Let's get this guy's comments out of here. It's our program now. So else, what can we do? Well, we know we can look in any of the directions. So if we look that side, we'll see something. We've got data cube, worker, a wall. Oh, we have other directions. That's the cool thing about this. Look, we can look up in that direction. So if I look up in that direction and I see a worker, then that means the person to the left of me went up. Cool. And dropped their data cube. So if to the left of me I see a data cube, then I think I should step down and drop mine. Now everyone else who doesn't have a wall next to them or a data cube to the top right of them, we just want them to do nothing, right? For now. Let's see if that's what happens. We step. So she doesn't have a wall, so she just jumps out of that. She doesn't have a data cube to the top left, so she jumps out. All right, she just sits at the end of the program, which is not what we want. We need to send her back around to try again, right? So if to the left of you is a wall, so you go around to the jump. Now you jump back up to the top. Still left of you is not a wall, but now look, left of you is a data cube, so you step down. And then back up. Now you're going to keep going around. Everyone's going to keep going around. So we can probably stop them from jumping out. Good. Let's stop her from going round and round and round over the time by saying that, whoa, when we get down to the bottom, do have a bit of trouble placing things with the ifs. If me equals nothing, then, oh, I don't have the end statement yet. Okay, we'll let them keep going around. End came later on. We'll just let them cycle around forever and ever doing nothing. So now we can guess that if where we're standing we see someone below us, we should be stepping up. So we got another if. Now it belongs in that else there. Yep. It's also an else to this one here, but we don't need to nest them, so we won't. I always avoid nesting if I can. If down there is a data cube, then someone went down, so you should go up. Step up and drop. And now I think they'll all do nothing until one of these conditions is true, right? Trying to. So he puts his down. She realizes, puts her down. He realizes, puts his down, down, down. All right, good. So it's quite slow in the sense that they're sitting there doing nothing quite a lot of the time. It would be nice if we could make them all move, you know, at the same time. Boom. Just unzip all in one go. But I don't think we have those. And you can see they're wanting us to do it in 7 seconds. So probably that's a version where they do it much faster. But I like that answer from a theoretical point of view. Because again, each of the humans, each of the processes is using the data around them to infer what the other processes have done. And that's really called a concurrency. Yeah. We often think of concurrency as processes talking to each other. But a process has no voice. A process's only way of talking to some other process is to drop a value in memory somewhere that the other process is looking at. And that's exactly what's happening here. We're dropping a 0 in a slot on the board that the other process, the other human, is looking at. And then they're judging from that what to do. And the other concurrency thing here we're seeing is that just spinning, doing absolutely nothing, spinning round and round until some condition becomes true that tells you you can do what you want to do. And this guy up the end here, he was spinning for ages. If we watch him. What? Why is he talking about candy? Interesting. Let's watch him. He just spins and spins and spins, doing nothing. The ifs are all coming up false for him. False, 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 false. Until finally, he's got something to do. Done. Let's do another one. That was much easier than last time. I had a terrible solution to that. I'm going to find my solution that I did last time and show you that one. It was terrible because I didn't twig to that idea that if I had them just doing nothing until the condition became true. I was trying to make what's the condition for every one of them at the start. So I had a fast solution at the start, but it was not nice. Let's have a look at 11 injection sites. Sounds controversial. Oh, I remember these ones. Important data cubes from management have to be put into the empty slots. So there are actually 2 of these that I'm not sure brought. Oh no, they did. put them down on the floor where on the horizontal lines, most of them anyway. So for every one of these people, there's a blank slot in front of them. So they're just going to be walking towards the blank slot, and when they find it, they drop it down. Notice though that there are a ton of blank slots here that don't count. So the condition is a little bit more than just there's a blank spot. So we certainly want to pick up in front of us. And then we certainly want to step forwards. And we certainly just want to be looping that over and over again, but at some point stop. So now we're looking for the condition that we put in here. And I think it's fairly easy, because I think the condition is underneath me is a nothing. And to the left of me is a something, is a data cube. I mean, that's all. Every one of them will see one on the left of them when it's time to drop one. Yep, they all will. Then that's the time I drop. And they can just keep walking, that's fine. Cool. Alright, so they're filling in the gaps. Alright, anything new to learn from that? No, probably not. Oh, what they've done for us, sorry, the new thing was that they showed us, it was always there, I think, the and the ors in the if statement. And then this one was similar. Let's do shredding. Let's move on to something new. Shredders. These things are horrible. They eat you. Shred anything dropped inside. And then the people have a bad habit of like jumping inside. I don't know why they do it. What we're getting at here are, and soon will come printers as well, are kind of producer and consumer processes we can use. So this is how to make data go away. At the moment, data has just either existed already in memory, well, it's only just existed already in memory, that's it. This allows us to make data go away by dropping it in a shredder. So we got the new give to command. So I need to pick up what's in front of me if there's something in front of me, because this person doesn't have something in front of them. So I'm going to put this in a big if. If that way is a data cube, then pick up what's in the data cube. Step forward once, I think, and give to what's in front of me. I think that's all I have to do. Pick up, step. Can't give my item to nothing. Oh, there's a blank slot there, so we've actually got to step forward twice. Go. They didn't jump in. Good. Last time I did this, they all jumped in. I think because I didn't have the if around it, so that person would just walk in. Oh, that's right. If you're not holding something in your hand and it says give to the shredder, you give yourself to the shredder. All right, let's do one more. So I've picked up a couple of concurrency concepts here. Well, one in particular, this kind of, well, we picked up the deadlock. And the other one was the looking around us for data to communicate with other processes. Let's shred all the data cubes. So we're picking up all the data cubes. They're introducing us to another command, which is end, which allows us to not just spin idly when we get to the end of our program. So we are going to, they've all got more than one in front of them. This time they got exactly 3, so I suppose I could count it out, but I'm not going to. I'm going to use a jump. We've got this starting up with the loop. And with the loop, I will always look underneath me to see if there's data cube. And if there is, I will pick it up. And then I will start stepping downwards. And step downwards. And then I'm in the step downwards loop, trying to find the shredder, right? So I best not be stepping downwards if I see the shredder. So if below me is a shredder, then give to the shredder and jump out of this loop because I don't want to be stepping down anymore. Head back up there. Ooh, this one's getting complicated. This is the step for finding a data cube, picking it up, and then just stepping down over and over until I see a shredder and giving it. But I haven't even picked up one yet. So what I actually want before I get to the shredder is to step up looking for a data cube. So step up each time round. Is that all? Yeah. Chuck it in, head back round. Nice, didn't even use the end, so they're probably all going to run into the shredder now or head up to the wall. Let's see what happens. They put their hands out there before they chuck something in the shredder. For those who are curious, this shows up more in Human Resource Machine, but you're probably getting an idea now why we stopped using jumps, which were called go-tos. Well, they were called jumps in assembly program and go-to in languages like BASIC, for controlling our operations. Nice. We can make it faster just by putting the end in. Let's do it. If you're hitting a wall at the top, then end. So before you step up, check to see if above you is a wall, then end. Right, let's run that fast and I'll just talk you through what I mean. Here we're using loops for breaking out of... Oh, that was too quick. I'll have to go back. 38 seconds. I've got to do it better. Here we're using jumps for getting out of if statements that we're no longer wanting to run in, and for looping, and there's 3 loops going on here. And imagine programming without these graphical advantages. You don't have the line showing you where you're jumping to. This jump would just be like jump line 5.5, you know, in between those 2 lines. And it gets very hard to keep track of. So the jump to loops, the change to using loops for programming was quite a big one. So the famous paper to go with that is called "Go-to Considered Harmful," and it seems quaint these days because it's quite obvious to us that go-to is considered harmful, but it wasn't just trivial to convince the world that they should stop using go-tos. All right, I think we're done for today. Hopefully you got something out of that. Thank you, and I shall see you next time.